Let's talk about the inverse of a 2 by 2 matrix. Let I equal 1, 0, 0, 1, A equals 1, 2, 3, 4. Find IA. IA is 1, 0, 0, 1 times 1, 2, 3, 4. You recall how we do this. 1, 0, this row, times this column, 1, 3, is going to be 1 times 1 plus 0 times 3. In other words, 1. If we do that for all the entries, we end up with 1, 2, 3, 4, which is A. I, 1, 0, 0, 1, is the 2 by 2 identity matrix. Sometimes we designate this as I2 because it's two-dimensional or 2 by 2. IA equals A for any 2 by 2 matrix A, and AI equals A as well. Here's an application. One way to solve the equation AX equals B is to multiply both sides by a matrix that turns A into I. When you do that, when you multiply both sides on the left by something that converts A into I, the left side is now just going to be I. Well, IX, really. And the right side will be something. But IX is just plain X. So we have X equals something, and that will be our solution. So this matrix, in other words, this matrix that we're multiplying both sides by, would be the inverse of A. The inverse of the n by n matrix A, in other words, is the matrix A inverse, that's what we call it, such that A inverse equals A inverse A equals I. Here's the special case of a 2 by 2 matrix. The inverse of A equals ABCD is A inverse equals 1 over AD minus BC times this matrix, D, negative B, negative CA. Notice that to get that matrix, you just interchange these two. You interchange the A and the D, and you stick negative signs in front of the B and the C. If AD minus BC equals 0, then A has no inverse. There is a special name for AD minus BC, this denominator that's out front. The determinant of the matrix ABCD is AD minus BC. So what I've circled here is what we call the determinant. We denote it by this. Notice it looks just like a matrix, except we don't have the little, you don't have those little bits on the end. It's not a bracket, it's simply a vertical line. And we denote it by determinant of A, or you can just put these bars around the A, these vertical bars. Okay, let's see an example. Let A equal 1, 2, 3, 4. Find the determinant of A. If A equals ABCD, then the determinant of A is just AD minus BC. In other words, it's the product of these two minus the product of these two. So that's just going to be 1 times 4 minus 3 times 2, which is 4 minus 6. In other words, negative 2. So that's the determinant. Okay, let's find the inverse of A. Find A inverse. If A equals ABCD, then the inverse of A is A inverse. It's 1 over the determinant of A times D, negative B, negative CA. In this case, it's 1 over negative 2, because we saw the determinant was negative 2. We interchange these two guys. Okay, so interchange the 1 and the 4, and you've got a 4 here and a 1 here. Stick negative signs in front of the 2 and the 3, and you have negative 2, negative 3 there. And when you multiply it out, you get negative 2, 1, 3 halves, negative a half. Let's check. Let's make sure that really is the inverse. A inverse had better turn out to be the identity matrix. A is 1, 2, 3, 4. A inverse is negative 2, 1, 3 halves, negative a half. Multiply all of this out. Again, this row times this column will give you 1 times negative 2 plus 2 times 3 halves. You do that for all the other entries, and you end up with negative 2 plus 3, 1 minus 1, negative 6 plus 6, 3 minus 2. In other words, 1, 0, 0, 1, which is the identity matrix. So it worked. That really is the inverse of A.